Alright, give the stream a few seconds to warm up. Okay, alright, let's get started. So last time I was looking at computing the average and standard deviation of the capacity for this station versus hour of day across all the data that I had. And I actually made a mistake. I was calling that a histogram, that data, or that, I was calling those plots histograms, but they're actually not histograms. I was getting the terminologies mixed up, so that was my mistake. And I was actually just looking at the average capacity. But I actually do want to look at histograms, and that is what I want to do today. And right, last week I was also, last stream I was also ending with selecting the day of the week, as well as the day, as well as hour. So yeah, today I was thinking I want to actually look at the histograms, actually make histograms this time, but I want to look at how much time, so the purpose of the histograms, right, is to basically do things like look at how much time does the station spend at different levels of capacity, right? And so what I essentially will hopefully be creating is a probability distribution of capacity, right? So this distribution will tell me, 40% of the time, for example, the station is at 30% capacity, and then 20% of the time it's at 60% capacity, etc. And the real purpose of looking at this histogram, and why I kept thinking about histograms, was because this is really important. But this is a really good measure of deciding how healthy a station is, because a healthy station should see something like a histogram which shows a normal distribution centered around 50%, right? So the station is always has enough bikes for people to rent, and is never too full, and it's never too empty. So yeah, let's get that going. So going back to where I left off yesterday, right? Yeah, the first thing to do is just to correct this, which is to say that we're not looking at histograms here. This was just plotting the averages of and the standard deviation of capacity versus hour of day. I think another thing I was looking at was grabbing, hour and day. But I wasn't using that data yet. I was just plotting things with that. So I'll actually continue down here. And I'll also make a comment, leave plot showing for last. Okay, great. So what I want to do, right, I want to count every time the station is between certain range of capacity, and then do this for all range of capacities, and that gives me a histogram plot, and then plot histogram. Alright, let's give that a shot. Right, so the first thing I want to do is take it piece by piece. The first thing is to see if I can count the number of times the station is between a certain range of capacity. And I think this is actually pretty straightforward, right? Because all I have to do is be like, I already know how to select, create a Boolean that tells me when the capacity is within a certain range. And I just need to count the trues in that range, right? So I just need to say, I need to look when, let's say, let's look at, let's say I want to look in 10% increments of capacity centered at some value, right? So let's say center capacity value, let's say this is 50%, right? and then I'd say capacity range. Let's make that 10%. And then I will look for when capacity versus time is greater than or equal, and I guess I will leave it lower limit is inclusive, higher limit is exclusive. So capacity versus time is greater than or equal to center capacity minus capacity range over 2, right? And let's copy this. Capacity versus time, we'll expand this a bit, is less than, so exclusive, center capacity plus capacity range over 2. Right, and I think I probably need a couple more parentheses. Cool. Save that to some variable, and I'm pretty sure Python will let me multi-line this. And I will call this index capacity within range equals this, and I think I should be able to check that this is working by plotting this. So let's say debug plotting when capacity is within chosen range, right? So go plot.figure, and I guess this would be the third figure. And then I'll do plot dot, oh, and another thing, these don't have to be bar plots. They actually don't make sense as bar plots. Actually, these should be scatter plots, but I can do that actually just by changing the display option. Okay, and then plot. I will plot. I'm looking for all the data and then the data in the selected range where we have the indexes that show us, yeah, when the capacity is within that range. Oops, what happened here? Oh, weird. Okay, Sublime's doing something. All right, here we go. Oops. And then this one will just be all the data. All right, and I don't need this. This is working. So this line plots all the data over time. This line only plots the data that this code should have found if it's working in between of the selected capacity range, right? So centered at 50% plus minus 5%. And I'm not gonna give it a legend because I know what's what. So let's just plot it. Not syntax. Oh no. All right, there's a new line. I believe there's a new line. Yes, I think that's the new line character for Python. All right. Oh, did it work? I think it did. Yes, it did. It looks like it did work. Cool. Perfect. So now what I want to do is I want to count the number of instances that this occurs. Right, and that'll be one entry in the histogram. So easiest thing is probably just to look for a Python function that does this, because one almost certainly already exists. Count number of true in array. Yeah, NumPy should be able to do it. Count the number of true elements in a NumPy array of booleans. Perfect. We use NumPy.count non-zero. Okay. Kind of a strange name for that function, but I guess if it works, it works. All right, let's give that a shot. count number of truths. I'm just going to print this because I just want to see if it works. Well, you know what? I'm going to add a debug here as well. So I remember to remove this code later. I don't need it. It's not essential. But print this. I can also do a very simple test case where I make my own array. That will be a sanity check. Close all these. Oh boy, now I have too many plots open. Name true is not defined. Oh, right. I believe in Python it has to be capitalized. Oh, shoot. I forgot to set a timer. Alright, I will set it. I'll set it to 25 minutes from here. Let's see that. Did it work? I think it did. I got number 2 here. 2295 here. Okay, cool. Great. Great. So now all I have to do is repeat this code, but in a loop. So count all instances of capacity within each range percentile. Let's call it percentile. Right, so num cap within percentiles equals well, I guess first thing is to decide what these percentiles should be. And I think I'll go with 10% increments from 0% to 100%. Yeah, let's do that. So I want to have a linear array from 0 to 1 in increments of 0.1, right? This should be easily done in NumPy. I just need to know what the function is. So I'm going to look NumPy, make linear array. Linspace, cool. This is probably what I want. Start, stop, num evenly spaced samples, calculate over interval. Okay, I see. This is similar to the MATLAB linspace, which is okay, but there's another one that I want, which is defining the step instead of the number. Yes, this one I'm looking for. A range, very number of positional arguments. Cool. Stop. Okay. Okay. Wait. For linear arguments, the function is roughly equivalent. Okay. When using a non-integer step, such as 0.1, it's often better to use numpy.linspace. Really? Why is that? Huh. Interesting. Okay. Well, they're going to suggest using this, so I guess I'll just use this instead. It's a little bit annoying, because that's different than what I would have done in MATLAB, but that's alright. Okay. We will say, let's say, center percentiles equals, so that'd be the center of each bucket. That's in space. Start at 0, stop as 1.0, and num should be 11, right? If we want to step from 0 to 1 in increments of 0.1. Of course, we can print this to confirm. Yep, looks good, looks good. Great. I'm actually going to delete this. Don't need it. And then this will be an array with oh right, and I'll also specify percentile range. So if I want to just hard code that, a number of capacity within percentiles will be the same size as center percentiles. There should be a size function actually. Imply size. Let's see. Yep. Number of elements in the array. Okay. Because I'm pretty sure I can be like this and initiate one empty array from another. Is it a function? Or is it just a, no, it is just a property. Okay. Let's try that. You know what, I'm actually gonna not plot things to make debugging a bit faster. And then I'm gonna say for right, let's say I% in range length center percentiles for each percentile of capacity, count number of instances, and save. This could definitely just be a list comprehension. Well, okay, how about I write this out as a for first and then see if I could turn it into a list comprehension. But I'm pretty sure I can. In this case, it'd be definitely preferred. It's just one line of code. Number of capacity within percentiles, I% equals, it should be, what was the function that I needed? np.count non-zero, so that counts the number of trues and falses, right, of this stuff. Yeah. This is probably enough code that it could be more useful to have this in a function, but that is okay for now. For these purposes, I'm just doing some quick scripting, doesn't really matter too much. So capacity is time greater than equal to, so the center capacity will be center percentiles I%, right, here as well. Center capacity I% minus percentile range of 2 plus 2, and that should be it. That should be it. And for I%. Okay, and then go ahead and plot a histogram of this. So we plot. I guess I will have to bring this back in. I wonder what happens if I actually don't name this one. Okay, and then because it's getting annoying to have to name all of them. And then the x-axis will be, well, this will be bar. X-axis will be center percentiles. The y-axis will be the number per percentile. The bars, so we're not applying dots. And then this is actually a histogram. A histogram of capacity, time spent in each capacity percentile. X label is capacity percentile, and then maybe I say plus minus 5%. Hopefully I don't have to escape the 5%. Y label is counts within capacity percentile. Okay. Alright, let's give that a go. I think it worked, although it's kind of funny looking. Oh, weird that it goes all the way up to 1.25, right? Center percentiles. We already know it's plotting the right things. Alright, I think it's time for me to double check how this bar function is working. NumPy, oh sorry, matplotlib bar graph. X, the x coordinates of the bars. See also a line for alignment of the bars to the coordinates. Height, width, 0.8. Yeah, this should be doing the right thing. Something about this looks strange, right? It looks like there's like, well, all the bars are kind of bleeding in together, and then also, why is the range going from like minus 0.5 to 1.5? That's not 1.5, that's like 1.3, I don't know. Very strange. I want to know why this is happening. Maybe if I just change this width parameter real quick, make it something narrow, see what happens. Huh, weird. Why does it look? I kind of squeeze everything a little bit, but it didn't actually do what I thought it would do, which is make each bar narrower. That's strange. Okay, maybe it's time to read the documentation. So matplotlib pyplot.bar makes a bar plot. The bars are positioned at x with the given alignment. Okay, the default is center. The dimensions are given by height and width. The vertical baseline is bottom, and default is 0. Many parameters can either take a single value, applying to all bars, or a sequence of values, one for each bar. Alright. X is the x coordinates of the bars. It can be float or array-like. See also a line for the alignment of the bars to the coordinates. Sure. The height is the height of the bar. Okay. Width, float or array-like, default 0.8. Width of the bars. Bottom, float or array-like, default 0. Okay, that one's I'm not going to use. And align, alignment of the bars to the x coordinates center, which I'm pretty sure is what we want. Okay. Yeah. Very odd. Let's do a little bit of debugging. First thing I always lean on is just printing values out to see what the heck I'm looking at. And in the future, I'm going to want to move to a more sophisticated development platform, I guess, because working in the command window is good for quick hacking, but it only gets you so far, especially when you're crunching data like this, big data sets. You need something that visualizes data a bit quicker. Okay. Well, looking at these values, it does look kind of strange because these values don't seem to really line up with what I'm seeing here. This value does, and then this value does. That's the second one. But then there should be a value of 2000, and it doesn't even look like it's showing. This is very odd. Okay. What am I planning on the x-axis? Yeah, center percentiles should be right. Should be right. Is the number of elements correct? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Yeah. Yeah, okay. Well, that's annoying. I do want to know what is going on here. Well, one thing I can do is just, if I don't want to think about it, I'll just search for this. Let's say matplotlib bar graph, x-axis incorrect, scaling or something. Yeah. Okay. So this person plotted this bar graph, really simple. Looking at x-axis, it shows the bar and values 0.75, 1.25. Huh. 1.75, 2.25. Well, they don't even exist in exercise list. Exercise list is 1, 2. No, I think this is showing correctly. What exactly do they want? So what you wanted, here's the full code. I'm not following what they're saying here. Generic way of setting the X labels in the middle of the bar. Okay, that wasn't really helpful, but I had an idea. How about I just plot one value and see what happens? Because why does it look like these values aren't centered in the right place? And then the bars are like too wide or something. Oh, you know what? Could it be? Oh, maybe width is not. So I thought width was relative for some reason. I don't know why I thought that. Maybe width, this is absolute units. So if I said it's 0.5, then it's like plotting plus minus 0.25 around 0. Okay, that must be what it is. I actually really want this to be percentile range. And then do I want to give it some space just for visibility's sake? Well, I don't know. Let's see. Oh, right, and I'm only applying one value still. And is there a way for me to actually close all the other figures before I open this one? Matplotlib, close all figures. Closes all the figure windows. Alright, let's try that. Close all other figures. Plot.close all. Run that. Oh, okay. Well, that's interesting. That is very interesting. Yeah, that's funky. That there's this, well, okay, yeah, a few different things, right? First, there's this weird, like, kind of staircasing happening, or not staircasing, there's like smokestacks coming out. And then the other interesting thing is that this distribution is heavily skewed, like very heavily skewed towards lower values. I think what I should actually do is change the percentile range to be something different, because I think 0.1 actually is causing some kind of discretization issues, which is causing this like smokestacking. I think these two should be bundled together. These should be bundled together. Right. So I actually look in 20% increments, and I want to be able to automatically update the linspace that I'm doing here to calculate the centers. So I probably should make this number some kind of rounded value of this maximum value divided by percentile range. But this will be 6, right? Not 5. If I divided it, it would be 6. Let's try this. I will round that value and then add 1 to it. And that'll be my solution for now. Python round. Sure, let's look for numpy. Numpy.round. Yeah, see, this is annoying because what I'd rather do is just use the MATLAB syntax where I can go like, I specify the first number, I specify the step, and I specify the last number. Which is what that arange function is supposed to do, but I don't know, it seems like it's not really doing it right. Anyway, well, according to the documentation, maybe it works, you know? Maybe, you know, let me just give it a shot. Oops. Okay, so the percentiles equals numpy.arange. Right, we'll start at 0 and at 1, and the step size is percentile range. And then everything else is the same. I don't have to change anything else. Let's give that a go. Oh. Okay. So why wasn't it giving me control back? Okay, there we go. Yeah. Looks like we're definitely centered around 0.2. And it looks like this arange actually looks like it didn't quite capture the range around 1, which you know what? Another thing I just realized too, this is actually not really correct because like I shouldn't be trying to look for data that has negative capacity or capacity above 1. So this should actually really start at like percentile range over 2, and then this should end at like 1 minus percentile range over 2. And steps of percentile range. Let's run that again. Yeah, that looks good. I think this might just need to be bumped up a little bit so that the float rounding or whatever's going on can capture that last bracket, that last percentile. Nice, cool, all right. And actually, now that we've done this, I want to go back and see if I can make this a more finer resolution again. That's one of the trade-offs with histograms, is that you want to find the right sort of bucket size to capture your data in a meaningful way without introducing some kind of like grouping artifacts. Wow. Well, that is interesting. Okay, well the shape is still a bit more unevenly distributed than I think it really should be, so I'm going to kind of mess with this a little bit. What if we go with, so a smaller step size and a smaller bucket size gives you technically higher resolution with your probability distribution. Oh, but you can end up with something like this, where you are actually, because our data is discretized, right? We actually have certain values that are not even like possible, which is funny. You know what? One thing we can do is actually calculate what values are possible, because we have the number of bikes. And so I would just want to step in whatever percent is 1 over the number of bikes, right? And to get that information, I have conveniently also loaded, yes, this variable right here, COMAV station capacity. It should tell me the number of bikes that we've got going on. 15 is the number of bikes. So I will make this, where's this? Percentile range 1 over, what was that variable? COMAV station capacity. 1 over COMAV station capacity. That'll be 1 over 15. I could leave that printing, I guess. That doesn't bother me. Run that again. Oh, what the heck? Wow, weird. It's still not showing. I was expecting a much smoother curve. Huh, okay. Should think if I am calculating this right. I think I do actually want to start at 0 and end at 1, like inclusive, because you know what, this plus minus is like not even really important, because you will the values are discretized, so you should only be finding values at like 0, 1 over 15, 2 over 15, 3 over 15, right? Yeah, I think so. So this would actually start at 0, and this should just start at 1, or end at 1, and I will change the descriptor in the X label. Capacity percentile. Okay, I'll just leave it as that. Because I could also make this instead, I can make this like count number of bikes instead of, you know, the ratio of number of bikes to total docks. Ah, okay, there we go. That looks good to me. Yeah. Yep. Okay, yeah, I think this is very informative. Oh, there's the timer. Oh. So I'll end it here, but this is a good place to end, because now we have a histogram of how much time this station spent in each possible capacity value that it could have, right? And this data essentially gives you an estimation of the probability distribution of this capacity of the station, right? So this is saying that, oh, you're going to find it much more likely to find your station totally empty, and actually this is this proves my point very well, that this station is very underserved, is that it spends the most of its time, the most likely scenario that you'll encounter at the station is that it's totally empty. That's what this plot is saying, and that the likelihood that you find it at 100% full, right, is near 0. And then it's actually a linear distribution, which is interesting. It's not a normal distribution, it's not uniform, it's this linear distribution. And I don't know enough about statistics to say what that means exactly, but very interesting looking trend. Alright, well, I'll cut it off here and continue next time.